Hello friends, welcome back. In this video lecture we are going to see about one numerical on a 3-bus system in which we are going to determine some quantities at the specified buses of this given power system. Okay, so let me just write the here the statement of the example. Okay, so a 3-bus system shown in figure below is 3-bus system is shown in figure below. Assuming assuming a flat voltage start assuming a flat voltage start find the values of v2 v2 del 2 q3 and del 3 at the end of first iteration of Gauss-Seidel method of load flow. Okay, so the given bus 3-bus system is as shown in figure here. Okay, so the 3 buses are numbered: bus number 1, bus number 2 and bus number 3. Okay, so now here bus number 1 we usually assume as slack bus. Okay, and here they have given some other information also regarding the transmission lines connected between these buses. Okay, so let me just write those information also here. Okay, so here for the bus 1 what is mentioned is, so it is a slack bus, so here the voltage is mentioned, and that voltage is given as v1 1.05 at an angle 0 per unit. Similarly here p2 is given minus 4.0 per unit, and q2 is given, so minus 2.5 per unit. Okay, and then for the bus 3 they have given active power p3 equal to 2.0 per unit, and bus voltage v3 equal to 1.04 per unit. Okay, and here, so when it is given as a PV bus, so we know that for a PV bus reactive power and the phase angle will be the unknowns. Therefore here that reactive power, whenever we calculate, it has to be within a required limit, as we have seen it in the previous video lecture, that there will be a minimum limit that we need to consider for that. Okay, so I think it is available here. Okay, so I have given that line also: qi is greater than some specified value, then the maximum value will be taken, or if it is minimum, the minimum value will be taken. So these things are clear in this particular video lecture, so you can go back and watch that. So now here we are having PV value, so therefore q should be within a specified range, so that q for this bus 3 is indicated as q3, and that q3 is given as uh, this left hand side indicates the Q minimum value, which is 1 per unit, and Q maximum is 1.5 per unit. So it should be within 1 to 1.5 per unit value. So this indicates our Q minimum and this indicates our Q maximum. Okay, so now if suppose the value Q3 obtained is greater than 1.5, then whatever this 1.5 is there, that will become its Q reactive power value, so automatically it will become PQ bus. Similarly, when it is less than this 1 per unit value, at that time also the reactive power will become equal to 1 per unit, so Q will be known, so PQ will be known, so it will become PQ bus. But right now whatever specified is this. So similarly, along with these things, they have given the bus impedance information, so that we can obtain the admittances. So here between 1 and 2, that transmission line is connected, so it is indicated as Z12, and it is having the real part as 0.02 plus imaginary part as J.04 per unit. Similarly, between 1 and 3, Z13, so all of these are phasor quantities. Okay, so 0.01 plus imaginary part is J.03 per unit. Similarly, between bus 2 and 3, Z23, that value is 0.0125 plus J.025 per unit. Okay, so this value is given here. Now therefore these are the information specified along with the buses, and we need to determine the required values here, V2 del 2 and Q3 del 3. So let us now try to understand what are the types of buses given here. So in the first bus, voltage is given and delta value is given, so it is obviously a PV bus or slack bus, which is also called as a PV bus. Okay, because it is called as a slack bus because here the voltage and the phase angle delta is given, so it is a slack bus. Similarly, the second bus is having P and Q value. Okay, so active and reactive power is given, so therefore it will become PQ bus. So this bus is a PQ bus. Okay, similarly the third bus is having P3 and V3 value, so therefore this bus is a PV bus. Okay, so PV bus. So here for the PQ bus, the unknowns will be, so here the variables will be what? Variables will be V2 and del 2, and here the variables will be, so P and V3 are known, so obviously Q3 will be unknown and delta 3 will be unknown. Okay, so we need to determine the values of this Q3 del 3 for bus 3 and V2 del 2 for bus 2. So here we have to apply Gauss-Seidel method, and we have to limit our analysis to just one iteration. Okay, so this is the given we can say information or problem statement. So you can pause the video and note down this problem statement and diagram, then you can proceed with the solution. Okay, so now to solve this example, so you have to first determine the Y bus elements. Okay, so therefore here impedances are given, but we need to know the admittances so that we can determine a Y bus elements. So therefore let us begin the solution here. Okay, so here what they have given is we have to start with the flat start. So flat start means basically we have to assume, okay, so while using the Gauss-Seidel method we have to assume the initial values. So here we need to assume the starting voltage. Flat start is voltage magnitude we have to assume as 1.0 per unit. Okay, and phase angle, that is delta, as 0 degree. So this is simply the flat start indicates. Okay, so we have to assume 1.0 per unit voltage value, and phase angle or delta value should be 0 degrees. Okay, so that is the flat start. So while simplifying, so our first assumption to begin the solution will be to assume voltage as 1 per unit and angle as 0 degrees. Okay, so therefore now let us determine the y elements or admittances. Okay, so the admittances are, so first of all, y12, small y12, small y12 is obtained as z12. All of these are phasor values, so even if I don't mention it, it is a phasor value, so having real and imaginary part. Okay, so now we need to calculate this. So substitute the given values of z12, z21 and z12, z23 and z13. Okay, so here first of all let us calculate this y12 by substituting the value of z12. So it is 0.02 plus j 0.04. Okay, so you can use your calculator and use the complex mode to determine the value of this. So you will get 10 minus j 20. Okay, so this is what you are going to get. So similarly y13 we can calculate by using 1 divided by z13. Okay, so substitute the value of z13. So what is z13 here? 0.01 plus j 0.03, 0.01 plus j 0.3, j 0.03 I think. Okay, so therefore simplifying this we are going to get 10 minus j 30. Okay, so here to solve most of the examples you will require a calculator like 991. Okay, so that you can do these calculations directly in your calculator. If you do not have, purchase one calculator and then do this calculations. Okay. Then next one is y13. So okay, y13 is obtained. Next is y23, between 2 and 3. So it is z23, 1 divided by z23. So z23 values are, so here z23 is 0.0125 plus j 0.025, 0.0125 plus 0.025. Okay, so calculating this we are going to get 16 minus j 32, 16 minus j32. Okay, so these are the admittances, line admittances. Now we have to obtain the elements of y bus. Okay, so therefore that y bus and how to obtain that already we have discussed in the previous video lecture, so you can go back and check it. So now directly we'll apply that and try to determine the y bus elements. So y bus elements of y bus. So elements of y bus are written in the capital letters. So for the bus 1, y11, so it will be whatever transmission lines are connected to bus 1 we have to consider. So one is the z12, another one is z13. So automatically here it will be y12 plus y13. So substitute those values. So here it is 10 minus j20 plus 10 minus j30. So simplifying it we are going to get 20 minus j50. And also at the same time, when we convert this rectangular form into polar form using the calculator, we're gonna get, and this magnitude as 53.8516 and angle as minus 68.191986. Okay, so 4 digits we will take. Okay, so this is the value of the first element of the y bus, diagonal element. Okay, so next diagonal element is y22. So y22 is also obtained in the same way. Whichever is connected to bus 2, those transmission line admittances we need to add. So we need to add, so y12 and y23. Okay, so because here for the second bus 1 2 is connected and 2 3 is connected. So therefore here let us substitute the admittances whatever we have obtained earlier. Y12 is 10 minus J20 and Y23 is 16 minus J32. Okay, so therefore simplifying this we gonna get 26 minus J52, and simplifying this we are going to get 58.1378 at an angle of minus 63.4349 degrees. Okay, same way third diagonal element is y33. All of these are phasor values. Okay, so you can see this is magnitude and phase angle, so all of these are phasor values. So similarly this y33 will be, so y33 is nothing but whatever connected to third bus. So what are connected to third bus? 1 3 and 2 3. So y13 plus y23. So let us substitute those values. Y13 is 10 minus J30 plus y23 is 16 minus J32. Okay, so simplifying this we are going to get, so 26 minus J62. Okay, so simplifying this further or obtaining the polar form of this, we are going to get 67.2309 at an angle of minus 67.2490 degrees. Okay, so same way let us find y12, the other elements. So y12 is nothing but also y21, and it is nothing but minus of y12. So just taking the minus sign of that, so minus 10 plus minus of minus, so plus J20. Okay, so also in the polar form this will be 22.3606 at an angle of 116.5651 degrees. Similarly y13 is obtained as also y31, that is going to be equal to minus y13, and that is going to be minus 10 minus of minus plus J30. Okay, so calculating in the polar form we gonna get 31.6228 at an angle of 108.4349 degrees. Similarly finally y23 will be, okay, y23 will be equal to y32, and that is equal to minus y23. Okay, and it is equal to minus 16 minus of minus plus J32. In polar form it is going to be 35 plus 7771 at an angle of 116.5651 degrees. Okay, so these are the y bus elements. Okay, so now what we need to do is we have to obtain one formula for determining the required quantity. So here for bus 2 we need to determine the variables v2 and del2. Okay, so we have to proceed in a way to determine the value of v2 first and also try to obtain the del2 from that. Okay, so that part we are going to do in the next video lecture. So till then you just understand this concept and write it down. Okay, I'll see you in the next video lecture. Till then, happy learning and thank you.